Okay, now we're on to part 2 of chapter 3. Again, remember we're talking about elements and we're talking about compounds. And elements, again, we have physical states of elements and we have chemical things that are going on with elements. But the thing to remember about elements is most of them are solids at room temperature. There's a couple that aren't. There's 2 that are liquids, mercury and bromine, and then there's the noble gases that are gases. We've got nitrogen gas, oxygen gas, hydrogen. So some, and especially the nonmetals, tend to be gases. But there's only 2 liquids, and this is at room temperature. So most of them are solids. That's their physical state. Okay. Now we can take elements and we can put them together and form molecules. Okay. So here's your atoms, like argon. This would be an noble gas. And when you put 2 of them together, or 3 or 10 or 200 or whatever, it doesn't just have to be 2. But here's nitrogen gas. Nitrogen is one of those diatomic elements. There's always 2 of them. So this is considered a molecule. Okay. There are 7 gases, 7 elements when they're by themselves. I shouldn't say gases because some of them aren't gases, but there's 7 of them when they're by themselves. When they're pure form, there's always 2 of them. You won't find a single atom. Instead, you'll find 2 stuck together, and they're called diatomic, 2 atoms. Hydrogen, nitrogen, oxygen, and then the halogens, fluorine, chlorine, bromine, and iodine. These guys, if you have pure hydrogen, you won't see it just 1 atom, you'll see 2. If any of you guys work in the health field, you'll hear oxygen. They always call oxygen O2 because that's what it is. There's always 2 oxygen together. You won't find a single. Now, that doesn't mean when they combine with something that there can't be just 1. Okay? Like water. Water's H2O. There's only 1 oxygen. Okay? But when they're by themselves, there's always 2 of them together. Okay? So those are called diatomic, and there's 7 of them. And later on, when we write formulas for equations, it's really important to remember the diatomics. Okay, so which of the following is not diatomic? Well, that would be carbon. Carbon is not diatomic. You don't see C2. You can see C2, but it'll be combined with other things as well. Okay, which of the following metals is not a solid at room temperature? Well, the one element we always know, we call it quicksilver, would be mercury. Mercury is a weird metal because it's really super, super dense, but it's a liquid at room temperature. And which of the following nonmetals is not reactive? Well, if it's not reactive, it's one of the noble gases. And if you look on your periodic table, you'll find out that's helium. Okay. So now if we take 2 or more elements, take their atoms, and we combine them, and they chemically combine. It's not just a mixture where you mix them together. They actually have to chemically combine, and they're going to have a definite proportion by mass. In other words, the amounts of each element is always the same. You have a compound. Okay. We have aluminum oxide, potassium nitrate, calcium chloride. Okay, these are their formulas because it tells me I have 2 aluminum and I have 3 oxygen. Now, if I change these numbers, it's not the same compound. Okay, most of the time it's a compound that doesn't even exist. Okay, here I got 1 potassium, 1 nitrogen, 3 oxygen. Okay, so you have the symbols to tell you what elements you have, and then you have the numbers below. These are called subscripts. And the subscripts tell you how much of that you have. And the proportion is always the same. Okay? All right? If you break this down into aluminum and oxygen, you're going to get 2 aluminum to 3 oxygen. Okay? So you can break a compound down into elements, but you can't break an element down. That's as simple as you get. Okay? Each compound has unique properties, and it's very different. Well, not super different, but most of the time it's very different from the elements you made it from. Let's see if I got an example. Here's, okay, water. Okay, you take water. Water is made out of hydrogen and oxygen. Hydrogen is a gas. Oxygen is a gas. Hydrogen is very flammable. If you remember the Hindenburg, the first blimp that like caught on fire because hydrogen was so flammable. Oxygen is definitely flammable. You need it for things to burn. But you put the 2 of them together and you get water, the stuff that puts the fire out. Okay, and it's a liquid. Here we have sodium chloride. Sodium chloride is made out of sodium, which is a metal, a very reactive soft metal, and chlorine. You know chlorine, that noxiously gassy stuff they use. It's a great disinfectant. They use it in pools. It burns your eyes. You put the 2 of them together and you get salt. Yes, the stuff you put on your food, the white crystals that flavor our foods. So they're very different. The thing to remember is that you can't change, when you're talking about these molecules, if you change the subscripts, you change it into a new substance, okay? Here's examples of water, and this is hydrogen peroxide, okay? Instead of H2O, I have H2O2. These two, even though they're made out of the same stuff, they're very, very different compounds. They are colorless liquids, both of them, but I'm telling you, if you're really thirsty, do not take a swig of hydrogen peroxide. It will not be good for you, okay? When you have molecules, that's the smallest unit of a compound. So the smallest unit of an element is an atom. The smallest unit of a compound is a molecule, okay? And the molecule is going to be the unit you're going to have your elements in the proportion that the subscripts say you have. And these numbers are always whole numbers. There's never like 2.5 or 1/2 or anything like that. They're always whole numbers, okay? And molecules do not conduct electricity, okay? Later on, we'll talk about ionic compounds where you form ions, where you have charged particles. They do, but molecules don't, okay? Here we have water, good old water. If we take water and we break it down, if we decompose it, again, we get oxygen and we get hydrogen. Both diatomics, okay? These guys, you won't find single elements, okay? Properties of water are very different than the oxygen and the hydrogen gas that they came from. You have gases, two gases make a liquid, two flammable gases make a liquid that puts out fires. So, you know, they're totally different than what they come from. So it's amazing when you can put these things together, what you can end up with. Okay. Which of the following is not likely to be a molecule? This one's a tough one because we haven't really talked about that much. But what you look for is if you have two non-metals, okay, you're going to have a molecule. If you have a metal and a non-metal, you're going to have what they call an ionic compound. They don't form molecules, they form ions. So if you look at all of these, the only one where you have a metal and a non-metal would be the very first one, calcium chloride. Okay, these are two nonmetals, these are two nonmetals, these are two nonmetals. So if you're looking for a type, you know, the ones that form molecules is when you have two nonmetals together. Okay, all right, so ionic compounds, what happens here is they actually transfer electrons and they end up having charges, okay? Like here's sodium chloride, salt. What will happen is sodium will give up one electron to chlorine. So because it loses one electron, it becomes positive one, because the protons still stay the same. And the chlorine becomes negative one because it picked up one electron. And they're doing this to be stable. And then they're attracted, the positive are attracted to the negative. So these are really, really strong bonds. But they form ions, okay? And there's two types of ions. The one that becomes positive is called the cation. Okay, the way I remember that is if you've ever had cats, when I had cats, when I came home, I was positive the cat was in trouble. So that's how I remember positive is the cation. And then the other one's called the anion. You can figure that one out any way you want. And you don't have to use that. That's just something I do because I'm old and have to remember things, you guys. But anyway, compounds are held together by these attractive forces by transferring electrons and making positive and negative ions, charged particles, okay? The formula is the simplest whole number ratio. In this case, there's always one sodium to one chlorine. So that's why sodium chloride or salt is NaCl. There's 1 to 1. You don't write Na2Cl2 or 3 to 3. You put the simplest whole number ratio, okay? And the thing about ionic compounds, they're all solids at room temperature. Most of them are what they call salts. And when I say salt, I don't just mean sodium chloride. It could be calcium chloride. It could be potassium iodide. Anything where you have a metal and a nonmetal is considered a salt. Okay? And when you heat them up and they get molten, and it takes a lot of energy to melt them, they're very good at conducting electricity. They use these a lot in the industries. Okay? So here we got sodium chloride. You know, here's our salt. It comes from the soft sodium metal and then that greeny gas. So these are definitely different than this. And again, that was like the water. The two things that make it up are very different than the product that's produced. Okay, so which of the following is true? Metals form anions with negative charges. No, metals form cations. Okay, metals become positive and nonmetals become negative. So it'd have to be C. Again, cations are positive, and that's going to be your metals. Anions are negative, that's going to be your nonmetals. Okay? All right. when you see a chemical formula, it tells you what's in there. And again, when you see these numbers, they're always whole numbers. You will not see halves or decimals or anything like that. Okay, so in this formula, I know that I have hydrogen, I have sulfur, and I have oxygen. And again, this is where it's important to remember, if you have a symbol and if you have a second letter, you have to make it small. Okay, because then you can really mess up your elements. And then these numbers, these are called subscripts, and they tell me how many have. So in here, I have 2 hydrogen, I have 1 sulfur, and I have 4 oxygen. Everything about this substance, as far as what's in it and how much of each is in it, is right here. This is actually sulfuric acid, the most widely produced industrial acid in the world. Okay, when a chemical formula contains more than one group, okay, so like in this case, we have parentheses. NO3 is what they call a polyatomic ion. In other words, it's a molecule, but it has a charge. And there's some of these, and later on I'll give you a chart with them. We'll talk about those when we start naming compounds. But this is called nitrate, and it always sticks together. Okay? In this case, in order to balance this out, I needed 2 nitrate groups. So anytime you have something in parentheses and a number on the outside, it's like math. You have to multiply everything on the inside by that. So this would have 2 nitrogen and it would have 6 oxygen. It's not adding, it's multiplying. But there's only 1 calcium. Calcium's not in the parentheses, so don't multiply that by 2. Okay? So we have calcium, we have nitrogen, and we have oxygen. We have 1 calcium, we have 2 nitrogen, and we have 6 oxygen. Okay? So this whole group, again, is called a polyatomic ion, and its name is nitrate. And in order to balance this out, we had to have 2 of them. So that's why we put in parentheses with a 2. And we'll talk more about that when we start naming compounds. Okay? In that formula, C12H22O11, how many oxygen? Well, that's pretty simple. It's right there, 11. Okay? Sometimes we got to figure out multiply. This is aluminum sulfate, which is baking powder. If you guys like to bake, there's baking soda and there's baking powder. They're different. How many sulfur atoms? Well, we have SO4. Here's our sulfur, but we have a parenthesis on the outside, so it should be 3. Boy, I'm glad I'm getting these right. That would be bad if I got them wrong, huh? And in this one, how many oxygen would we have? Well, 3 times 4, 12. Okay, and this might be our last one. I'm done with the notes for this chapter, you guys. Okay, ethyl alcohol. That's the stuff that makes your weekends a little bit more fun. How many hydrogen? Well, we've got it listed in 3 different spots. So we'd go 3 plus 2 plus 1. So we have 6. Okay, just because they're spread out doesn't mean they're not there. Okay, so we just add them together and we get 6. Okay, so we have carbon and we have hydrogen and we have oxygen, and then you just add up the numbers. Okay, and that's what a formula tells you. Later on, we're going to figure out how to write those, but for right now, I just want you to know and understand that. So we're done with the notes for this chapter. You'll have a little quiz, and then it's time to start reviewing. You're going to have your first test over the first 3 chapters. Okay, so that'll be our first unit test. I will have stuff for you to review. It'll be on there, so make sure you go through it. And if you have any questions, you guys, email me. I promise I'll get back to you. Okay? All right, that's it for this chapter, and we'll see you soon.